Good morning, everyone. Okay, so yeah, Varun, good morning. Morning, good morning. Shayan, good morning. Okay, let me start. So today, what I'm going to teach is a little bit complicated. It will initially appear to be a little bit complicated. It is the so-called B-free calculations. So if you remember when we were having the introduction, and it's roughly 5 weeks into the semester, and we already understand extraction quite well. We have even done the extraction, the continuous counter current extraction, which is from the handling standpoint or the mathematical standpoint is probably one of the toughest processes that you handle. What if you remember that I defined that in extraction, you can write or use three different type of approaches. One is the regular X and Y, which we have used, which is the fraction of C. But the problem of that is, or the convention that we typically follow is we use a triangular graph paper, right? So in last class, I have shown that for a continuous counter current process, in fact, it's easier for a cross flow system or for a single stage system. You can convert the XY plot, the triangular plot into an XY plot, right? If you can generate the operating line that we all saw. So there was no problem in that, but when you just plot it in the form of XY, listen to me very carefully, there is a problem. And the problem is for every point X and Y, you lose all the information of the composition of A and B. Now that is missing, right? Very similar to the XY plot that you have been using for distillation calculations, for the McAbthely calculations, right? And there also what happens is, now the class should understand clearly. Unfortunately, when I started, these concepts were not very clear. I saw that when you look into the XY plot in distillation, for every point, now the class understands that XY equilibrium plot is not isothermal. And what you miss out is the individual temperatures at every point. Similarly, if you recall, I have deliberately not kept the slides from the previous day's class. Similarly, if you recall, when we constructed or converted the triangular plot or the calculations shown on the triangular plot, right, into an XY plot for a continuous counter current system, right? So what we had the equilibrium data, and we had the operating line, which we generated by drawing some random lines from the difference point, delta R, right? The only problem was the XY. So at every point, the corresponding compositions of A and B were lost. So what I'm going to teach today is the so-called B-free calculations. I will first teach it for a single stage, and that's why. So it's 14th Feb today, so all the best to everyone. Have a great day. Have fun. Right. So this is a single stage calculation on a triangular plot. Right. And just one second. This is a single stage calculation on a triangular plot, which everybody now understands. And we are going to get started with the B-free calculation for a single stage extractor. One obvious question that will come to your mind and often gets unanswered is that we are doing it so nicely, so convenient, we understand this plot. Why at all we bother about something different? And you will find that when you are doing these B-free calculations, right, initially there are at least two places where there is a major assumption. Right? A major assumption is there, almost a mathematical singularity. Let me warn the class a priori so that when I teach, you do not grab my collar here, right? So we will see. And let me first teach how to go about it. And then I will discuss why this is important. Of course, this is there in the text. This is very classical thing. Therefore, it is important for you to understand. Many people skip it because it appears to be a little difficult to understand at the first go, and many people skip it. Now, that's not the right approach. And with an online semester, I do not know how the exams are going to be. Maybe end of February, we will have our first test or something like that. So that I will declare probably in the next class. Next class will be a tutorial class. I will solve some problems in the class. But let us first understand what we are doing. So if you remember the notations for B-free systems where X, which is the B-free composition or fraction of C, and N, X and Y and X, both are this. If you can go back to your old notes where I think in the second class I discussed the different notations. And this is more important in, so this is the B-free composition, fraction of C on a B-free basis. So what the hell this B-free basis means, we will talk about it. So this is the, composite, I have written B-free twice. So, and N is the fraction of B. I can assure you that if you follow this class on a B-free basis, if you follow what I'm teaching, you will understand everything. So let us draw a single stage extractor, which we are very well conversant with. So what we have is F and XF, S and YS, E and YE, R and XR. And you see, you are all experts already. What exactly does B-free calculations mean? The streams are same, right? But however, we are going to define a new set of streams, F dash, S dash, E dash, and R dash. So F dash, S dash, E dash, R dash are B-free flow rates. So what does it mean? It's very simple. Let's say if we are looking at E, E means A in E plus B in E plus C in E, right? What E dash means is A in E plus C in E. Similarly, F dash would mean A in feet plus C in feet, right? And probably the class should start understanding this should be equal to F. R dash should mean A in R plus C in R. Whereas in comparison, R would mean A in R plus B in R. You copy it in your scribble pad, but also take a minute to understand, please. So is this clear to all? Let us do things in a very simple manner. So this everybody understands. This is the total extract flow rate, right? Or the total amount of extract, and which comprises of A, B, and C. Now, when we are writing a B-free balance, right? When we are writing a B-free balance, we are defining a new B-free flow rate. You have to give me some 15 minutes time when you start understanding everything. So as of now, you are understanding what is B-free flow rate. You can say it's a mathematical entity. It does not exist because as an engineer, if you measure the amount of extract, or an experimentalist, if you measure the amount of extract, right, that is all what you can get. You either have to do a distillation or something to get rid of B and get this value of E dash, or what you are going to measure is only E. Is this clear to all of you? So we understand that we are defining a parameter or a flow rate which is on a B-free basis, but also remember this does not exist physically. Very similar to XM, right? There is no solution with composition XM, right? Is it clear? Because it splits up into two compositions which have, it splits up into two streams which has composition YE and XR. Is it clear to all? Others, come out of your Monday morning blue. We now define XF. Can anybody tell what is going to be XF? XF is C, composition fraction of C on a B-free basis, right? So what is XF? XF is going to be CF by AF plus CF. Is this clear to all? And, or maybe I will just move to the next page because this is sort of the heart of the whole thing. So give me a minute, please. So here we have a single stage extractor. EYE, RXR, SYS, and FXF. What we are doing is F dash, XF, NF, S dash, YS, NS, E dash, YE, NE, and R dash, XR, NR. Let me announce a priori that this B-free calculation will be performed or is performed on a rectangular graph paper. And therefore, to identify every point, you essentially need two coordinates. And that is the reason every point is not going to be, this is where students have maximum confusion. when you are shifting from a triangular plot to a Cartesian graph paper. In a triangular plot, what we actually do is we are marking XF, right? But if you are actually plotting the point, you are using two compositions. Is this statement clear? If it is not clear, it's my fault. I mean, next class we will probably take it up. See, if I say that XF, or forget about XF we know there is no B, right? But on this graph paper, if I say that draw a point with a composition of C is 70%, right? Let's say X is equal to 70%, 0.7. Can you locate the point? If I just say X is 70%, can you locate the point? Shayan, can you locate the point if I just say X is 70%? The answer is no. Whenever you are locating any of these points, right, something else must be specified, either the A composition or the B composition. You might say, sir, we have located XM. Yes, we have located XM. We have got a value of XM, but the value of XM would mean that it's a line that is parallel to the AB. Only the value of XM. We also know that XM lies where this XM equal to, let's say, 0.25 intersects the FS line. So some other coordinate must be specified. So you cannot really come out of this wrong notion that you need only one definition or one number to locate a point on a triangular plot. That's not the case. If you want to locate a point on the triangular plot, right, you must have at least two values. So X is equal to 0.7, 0.9, 0.8, this is 0.7, and this is A equal to 0.1. So now you can locate. So you see, already we are not defining, we are just defining the X fraction. But whenever you are drawing this equilibrium plot, for example, for all the points, for locating all the points, at least two of the compositions must be known. So it's already known, but we are just not using any symbol for that. We are taking the unique advantage of the triangular plot. But for locating every point, you actually need two of the compositions, even on a triangular plot. Is it clear? Any point, if you want to locate on a triangular plot, out of A, B, and C, you need to know at least two compositions. Is it clear? Clear to everyone? Onik, is it clear to you? Sahil, is it clear to you? Is it clear to everyone? Okay. So similarly, you need to know that for locating any point in any coordinate system, we need two of the compositions, two of the components. The compositions should be known. And we are going to use a rectangular graph paper. So every point, what we are going to define is the composition of C and composition of B on a B-free basis. This B-free basis is new, but what we are going to define is the composition of C and composition of B. So every graph, the graph is going to be something like this, X or Y. They are essentially the same, and we have N. So every point you would like to locate, right, you need two coordinates. Either you need X or Y and N. So keep this figure in mind, we will understand what it is. So now the class understands what is the difference, let's say again, between R and R dash. Let me just check. So R is going to be CR plus AR plus BR, whereas R dash is going to be CR plus AR. This should be clear to everyone now. Just check your own concepts. And similarly, F dash is going to be C in F plus A in F. And now I say not approximately equal to. In almost all cases, this is equal to F. This is clear to all? Why? Because F is equal to C in F plus A in F plus B in F. And in all cases, B in F is equal to 0, right? So therefore, F is actually C in F plus A in F. And therefore, it's equal to F dash. Is it clear to all? Is this clear to all? Adrija, is it clear why F is equal to F dash? Similarly, what about S dash? People, tell me what is S dash? Varun? Rishi Yaravar, are you there? Vardhan, are you there? Jyotiraditya, are you there? I will check the attendance list. Shayan, there is nothing called CF or 0. Others, can you tell? Shomik, can you tell what is S dash? Yes, Rishi. Next, AS plus CS. This is a solvent side. Indeed, it is AS plus CS. Thank God it survived. The class is still not getting the feel. You will get it. Don't worry. Solvent, right? If it is a pure solvent, have a look at S. I'm not very happy. Show me. So all of you, forget about S dash for the time being. No recycle. Forget about it. Show me. Pure solvent. Most of the problems I have taught you is with pure solvent. Actually, life becomes very easy in the LEC6 system if you have some impurity. So we have a pure solvent. That's the reason in most cases the solvent point coincides with B. This is clear to everyone? Bhavna, is it clear to you? Abhishek Purohit, are you there? Is it clear? Aditya Jha, Akhil Nama, Aman Kedia, Badri, Awais. Somebody started leaving. Jay, Vaishnavi, Ayush Surana, Bhagavati, Mausam, Muskan, Naman, Padamsi, Tejas, Rahul Goldar, Saksham Arya, Shankar Singh, Shivam. I'm just asking the class and others whose names I called, even if you are not understanding, you should respond. I'm just asking the class, what is S? Forget about A free, B free, anything. S is AS plus BS plus CS. This is clear to all. And it turns out that this is equal to 0 and this is equal to 0. Agreed? So in most cases, S is equal to BS. for a pure solvent. Agreed? S is equal to 0 for a pure solvent. This is clear to all? S is Bs for pure solvent. So therefore, what is S dash? S dash is As plus Cs. And therefore, what is going to be its value? Adamsi? Mosam? Bhavna? Tejas? What is going to be the value of S dash? Now it is simple. Yes, it's 0. Is it clear to the class that S dash is 0? Everybody has understood? And I repeat, these entities S dash, F dash, E dash, R dash do not exist. They are just some abstract stuff which we are going to use for the balance. Is it clear to the whole class why S dash is equal to 0? Come on, be responsive. Nobody will be going into so much depth and spending so much time for your concept. And everybody also understands why or how F is equal to F dash. Everybody understands this part? See, if you just read it, you take some note, but your concept will never be clear. Take it from me, you please follow this class today. So can I assume that the class understands F is equal to F dash and S dash is equal to 0? Show me, both are clear, both the concepts? Perfect. Anybody else who has some doubt? If not, let's move on. Now it's time we define certain things. And what is it? So what is going to be XF? Can the class tell me what is going to be XF? Rishi, can you tell me? XF, read it carefully. XF is going to be C in F on a B-free basis. So AF plus CF. Is this clear? Our normal XF is CF divided by AF plus BF. Just a minute. Everybody understands this? What is XF? This everybody understands, or let's say YE. Both these terms should be understandable to all of you, right? So what is XF? Capital XF? XF is CF divided by AF plus CF. And it turns out this is equal to small cf. Similarly, what is XR? XR is going to be CR divided by AR plus CR. YE is equal to C in E divided by A in E plus C in E. And here comes the problem. CS divided by AS plus CS. Look at these four terms. Are they clear to you? Are they clear to you? Onik, what is the question? Capital F or small f? What is the question? I did not get your question. I use the capital F, no? What exactly is your question, Onik? Can you repeat? XF and XF. No. F dash you mean to say? No. Please don't. That's a very good point Onik has raised. It shows Onik is trying to follow. See, so did the class, I appreciate these type of questions. You see the symbols here and the symbols here. So his question is, I understand XF versus F mapping, right? But now when you are talking about B-free calculation, why don't we map it with F dash? That's your question, Onik? Is that the question you have? So anybody else was having this doubt? I'm at least I can give a guarantee Onik is trying to follow the class very carefully. Answer to this is very, very well pointed. No, it's not even naming convention, Shayod. It's not even naming convention. You need to understand that though we are, that's the reason I was so excited with this question. Though we are defining these four streams, I repeat, none of these streams actually exist. I mean, you cannot isolate these streams, right? It is like 100 people, I won't probably give an example. Say 5 of your friends are running, okay, and 100 people, you are running in, maybe not the best example, forget about it. So none of these actually exist physically. They are more of mathematical entities. The streams are still P, R, F, and S. These are the value of the streams, right? Please do not confuse that S dash is equal to 0 means you are going to run an extraction system without solvent, right? Now, Onik's question has even more merit because somewhere we have shown that F is equal to F dash. And therefore, he is asking, shouldn't we write it X F dash? Answer is it's not required. So these are the B-free composition of C in the real streams. I repeat, B-free composition of C in the real streams. Nothing to do with naming conventions or anything. Once you understand how they are defined, you will not have this confusion anymore. Onik, do you understand? These are the B-free composition of C in the real streams. It so happens that for most cases, right, your feed is solvent free and therefore F is equal to F dash. Is this clear to everyone? And I am telling you, this is not the easiest thing. That's why I'm going so slowly and taking time. Is it clear to all? So all of the whole class now understands these four. Again, I would like to point out none of these compositions exist. The actual compositions that exist are this, right? These are the actual compositions that exist. This is again a mathematical entity. These are the actual compositions of the stream. Okay, but we are defining it. And once we start understanding, we get over this initial blue, you will start enjoying it. And the next set we define is the B-free composition of B. So what would it mean? BF divided by AF plus CF. NR is going to be B in R divided by AR plus CR. N in E, which is going to be B in E divided by AE plus CE. And Y in E, N in S, which is going to be BS divided by AS plus CS. Take a minute to convince yourself you understand. As of now, nothing much has happened. I told there are some assumptions. So the assumption set is now coming up. So for every stream, we can define a capital X or Y, right? And an N. Is that clear? So I'm repeating. So for the feed, we have XF is equal to C in F divided by AF, A in F plus C in F. And we have an NF, which is equal to B in F divided by A in F plus C in F. Similarly, for raffinate, we have C in R divided by A in R plus C in R, and NR, which is B in R divided by A in R plus C in R. Similarly, for extract, the X and Y convention remains exactly the same. I don't want to revisit it. A in E plus C in E, and NE is going to be B in E divided by A in E plus C in E, and YS is going to be C in S divided by A in S plus B in, A in S plus C in S, and NS is equal to B in S divided by AS plus CS. Take a minute and check if you understand all of it. Class, is it clear? And now, out of these 8 entities, so I guess the class now understands what is capital X or Y. It is the C fraction on a B-free basis in the real stream. And what about N? N is the B fraction on a B-free basis in the real stream. Now, amongst these 8 entities defined, 3 have the value of 3 you can calculate. You can straight away tell. Can you please tell me? Out of these 8 expressions which are defined, right? The value of 3 are known, assuming it to be a pure solvent. Padrija, can you tell me which 3 are known? Okay, the class is a little silent. Aman Kedia, can you tell me which three are known? Awais, are you there? Can you tell me which three are known? Naman, Tejas, Padamsi, Rakesh, Ronak, Samira, Sahil, Sajid, Saksham, Shoumik, Suraj, Vatsal, Yash, Rishi Aravar. Three are known. Yes, NF is equal to 0 is one set. Why the class is silent? People are having difficulty in understanding, or you have just logged on and gone in pursuit of 14th Feb. Celebrations have started already, or attempt to celebrate. Yeah, perfect. Ys and Ns turns out to be infinity. Why? Because here, what we have looked into, what is the denominator out here for Ys and Ns? The denominator is actually, and if you look carefully, so NF, for example, is BF divided by F dash. This is going to be BR divided by R dash. This is going to be BE divided by S dash, sorry, not S dash, E dash. And this is going to be BS divided by S dash. Similarly, one can write for each one of this. This is CF by F dash. This is CR by R dash. This is CE by E dash. And this is CS by S dash. Is it clear to all? Is this clear to all? And therefore, this is infinity. This is also infinity. Why? Yes, absolutely. We cannot even say indeterminate. Infinity is indeterminate. I mean, I really do not distinguish much between indeterminate and infinity. It's indeterminate, or whatever you want to write. But all of you understand that, and these are the biggest points of bones of contentions which are going to, not this one, this is B by infinity, but this one is indeterminate. Shoumik, I go with you. This is clear, but only this infinity problem comes for a pure solvent. And now you have to, you can imagine what is coming up. You have to handle this infinity in a graphical graph. So everybody understands that this is actually going to be 0, right? And these two are problematic cases, infinity or whatever, indeterminate. That is clear to all of you? Now the class understands. 6 people responded, others are not responding. Do you guys understand this? That out of these 8 capital letter stuff we have written, this one, Aman Kedia, are you there? These two are problematic. And this one is also luckily known, but this is no problem. This is 0. Rest of the stuff, you get some mathematical numbers. Is it clear? Okay. So if this is clear, then let us try to look at another new concept, which is the B-free material balance, B-free balance. Let's see how it is. So, and I know it is a little tough. It's oh God, it's 8:50 already. But by 9:20 or something like that, the whole class will understand what is going on. So let us look into the overall material balance. Let me also tell you the whole semester today's class is the toughest mathematical concept, and there will be the toughest physical concept I will teach the day I teach the concept of practical equilibrium in leaching. That's a physical concept, not a mathematical concept. But this is the toughest, mathematics-wise, this is the toughest in the whole of mass transfer 2. So overall material balance, all of us understand this. We are experts now. We write a B-free material balance. B-free material balance, it's an A plus C balance actually, which is nothing but A plus C balance. I kept on telling that these streams do not exist, but does not matter. So what you can write in A plus C balance, F dash, apparently it's very simple, plus S dash is equal to M dash equal to E dash plus R dash, right? Now, everybody understands what is F dash? Let me just write down somewhere maybe for your convenience. So F dash is equal to C in F plus A in F. Similarly, S dash is equal to C in S plus A in S, and so on, right? So S dash is equal to 0. Okay, for this balance, let me write down two things. Let me see if the whole class understands. Number one is F dash is equal to F, and number two is S dash is equal to 0. Just refer to the previous slide, and what you get in this case is M dash is equal to F. Check it out if it makes sense to you. This is clear to all of you? This particular thing comes from this balance. Is it clear to all of you? Why this is important? Because F is a physically measurable quantity. M dash, F dash, nothing else. However, with the help of your understanding, you can now correlate M dash, which is otherwise not a measurable quantity, to something measurable. So the importance of this equation is you can correlate M dash non-measurable to something measurable. Okay. I'm not even asking, is it clear? Okay. Now, so is this clear to all? Samira, are you there? Is it clear? This is clear to all? Bhavna, is it clear? Tejas, are you there? I think I called you several times. Padamsi, are you there? Rakesh, are you there? Is it clear? Everybody understands this? Okay. If you understand, it's great. Now, let us look into this term, BS. So if I write, so what is BS? B in the solvent. And if I write this is equal to S, I guess none of you have any problem. This is a solvent flow rate. for a pure solvent? Yes. Okay, now this I am writing as B in S divided by A in S plus C in S multiplied by A in S plus C in S. Now, mathematically, this equation is a valid one. All I am doing, I am multiplying the numerator and denominator with something. For a pure solvent, it turns out that both are equal to 0. But as long as I keep it only as an expression, this is a valid expression, yes or no? Here are the assumptions, and the assumptions are classical. So instead of challenging me whether it is right or wrong, whether you challenge or not, Treble's book is not going to change the approach. This is going on for 100 years. It is better we understand under what condition they have used these approximations. So if I now write, so what is BS divided by AS plus CS? What is BS divided by AS plus CS? This is what it is. So this is NS. And what is AS plus CS? What is AS plus CS, class? Samira, what is AS plus CS? No, Shayan, certainly not F. AS plus CS is not NS. No, neither. No, Adrija, I'm not even asking for 0. It is 0. Yes, it is S dash. Very good. Bhavna and Shomik. It is S dash. We are now looking only at the expressions. Adrija, Onik, Padamsi. You are writing the value. I am now looking at the expression. See, if you write the value AS plus CS is equal to 0, then we are essentially doing a mathematical blunder. We are essentially multiplying and dividing. We are inviting trouble. We had Acha Khasa BS. Now, what we are actually doing is we are multiplying in it and dividing it by 0. That is for a pure solvent. But I am now writing just the expressions. So what I am doing is I have BS. I am multiplying it and dividing it by AS plus CS. So that is the B-free solvent flow rate. Now, in an expression framework, we understand BS divided by AS plus CS is NS and AS plus CS is S dash, right? So that is what we are doing. And based on that, what we get is NS is equal to BS by S dash. This is an expression. And we know that for a pure solvent, this NS is going to be infinity. We know that. Okay. Now we do a C balance. And the C balance, we write a B on a B-free basis, we actually write. So what we have is F dash XF plus S dash YS is equal to M dash XM. Sorry, be very careful about this small and capital. Even I made a mistake here, you can see. XM is equal to E dash YE plus R dash XR. Okay. What is the normal C balance you write? Normal C balance you would be writing is FXF plus SYS is equal to MXM equal to EYE plus RXR. They are essentially same, Because what you actually look into, this term FXF is nothing but C in the feed. This is the C in the solvent. This is C in the extract. And this is C in the raffinate. So what is EYE? EYE is CE. E is CE plus AE plus BE into C in E divided by AE plus BE plus CE. So these two gets cancelled out. So essentially what you are writing is C in F plus C in S is equal to C in M equal to C in E plus C in R. This is the C balance. And instead of using the regular conventional thing, even if you write it on a B-free basis, it's essentially the same. So E dash is going to be C in E plus A in E, and YE is going to be CE divided by CE plus AE. So it gets cancelled out and they remain same. So this is clear to all why this is a valid C balance. So C balance, whether you write on a B-free basis or everything included, it's essentially the same. Because please do understand, this is again in the expression framework. This is the actual C balance. This is the actual C balance. When we are talking about C balance, it's going to be C in F plus C in S is equal to C in E plus C in R. That is clear to all. And therefore, if you break up each of the terms like this, like one term I have broken up, EYE, you essentially get the CE. And exactly the same way, if you now break up this term Y dash, or rather E dash into YE. So what is E dash? Samira, what is E dash? Varun, what is C dash? What is E dash? What is E dash? Very good. Samira, I asked you also, why no response? Perfect. A in E plus C in E. And what is YE? YE is CE divided by A in E plus C in E. So you see, this numerator and denominator gets cancelled. So this term also leads to C in E. Clear to everyone? This is clear to everyone? So EYE or E dash YE both essentially give C in E. This is clear to everyone? Yes? Odrija, is it clear? Rishi, is it clear? Samira, is it clear? Bhavna, is it clear? So therefore, this is also a valid C balance. So my point is that everybody understands that this is a valid C balance. Now I would write on a B-free basis. Okay. Now is the assumption. Now the assumption that we take is we look into this particular term S dash into ys, right? What about S dash? This is a horrible mathematics actually, but this assumption is taken. And I'm going to justify how we do it or how they have done it. This is clear to everyone. This particular term is the term which needs your attention. Shomik, Varun, Adrija, Samira, everyone. So this is the term. Now we know that S dash is equal to 0. And this is God knows what. So that's the problem. And the simple assumption that is taken is this is equal to 0. Let me write the assumption. This is an assumption. S dash ys is equal to 0. The logic being it is 0 multiplied by something. And we suddenly turn a blind eye to this, that this is indeterminate. This might be mathematically, so those of you who are very critical about mathematics, this might be mathematically wrong. But this is how this derivation progresses. This is taken as 0. And the way we have discussed, it should also be clear to all of you that where the problem lies. Please take note that this is assumed to be 0, and I have no hesitation in writing that this is not mathematically correct, and this is assumption, and this is assumption 1 actually. It's the first of the two major assumptions. So your equation now reduces to f dash xf is equal to m dash xm is equal to e dash ye plus r dash xr, right? Or we look into, so is it clear? I know there will be objections, there will be raised eyebrows, but is it clear? And therefore, I have been very defensive. I am telling the class this is the assumption 1. Is it clear? We now look more into, so these are all backup stuff. Okay. Who amongst you is not at all convinced? Is there anyone who wants to raise some objection? I'll get back to you. Even the people who do not speak, we will get you out. So what emerges? C balance gives f dash xf is equal to m dash xm, right? And what are the stuff we have proven before? What we have proven before is m dash is equal to f, right? And f dash is also equal to f. So we have already proven, we know f dash is equal to c in f plus a in f and is equal to f. And we have also proven M. Acha. So f dash is equal to f, and we have proven m dash, right, is equal to c in f plus a in f plus c in s plus a in s. That's the input for m. Now this is equal to 0. This is equal to 0, of course, for a pure solvent. And therefore, m dash is equal to f dash. So f dash is equal to f and m dash is equal to f dash. More important is m dash is equal to f dash. I mean, even if it is going a little over your head, it will become absolutely clear. So what you get here is xf is equal to xm. Now this is something very, very important. Very important. We will see. This I would like to keep on highlight. xf is equal to xm. Right? Now, I will recapitulate the whole thing, don't worry. So we have written a C balance. Now we write B balance on a B free basis. I will also share the PPT as usual, and my request would be to kindly go through, maybe before I write the B balance, I will take a little break and get a cup of coffee for me. I would like to request all of you to go through this exercise today. And this class, I am a little disappointed and annoyed probably the way the class behaves in the group, though all of you are very, very favorite of mine because I have been teaching you from CPC, but there are other groups and who are very appreciative of the fact that after every class, I share the PPT immediately. And there are courses that where recording is turned off, PPT is never shared, scribbles are horrible. So at least be gentle enough and decent enough, recognizing by writing a thank you, sir, does not cost you anything, but it gives a good feeling for me. Don't take things for granted. And I know I love all of you so much that I can tell this disappointment. This will help you to become a good human being in future. The way this class sits is okay, we are now third years, sophomore or God knows what, right? It's like RM sir's duty to make each one of us understand what the hell is going on in mass transfer 2, right? And it is also his responsibility to share whatever scribble he is doing. That's not the case. I understand the problem each one of you face, the difficulty you are facing in an online class, and therefore I try to make life as comfortable as possible. In return, I expect some decency. I hope, even if I'm sounding rude or brat or whatever, I mean, we are teachers, you are just like our kids, right? But when you go out to the professional world, when you face the world, these small, small things, you keep on sharing stuff in Facebook and Instagram. Smile doesn't cost you anything. A word doesn't cost you anything. Practice what you preach. I'll be back in 5 minutes' time. Okay. Before I write the B balance, let me just ask you one quick question. Is the coordinate of the feed point known at this point of time? Follow the question very carefully. Forget about other points. Is the coordinate of the feed point known? Why I ask this question? Because if you remember your single stage extraction, Rishi, just a second, please. If you had to start your single stage extraction on a triangular plot, what are the points you needed to mark? Feed point and the solvent point. And you join this Fs. Right? And based on some material balance, you would calculate M. Right? And from the graph, YE and XR emerged, right? This is how we have been making the calculations. Right? So YE and XR comes from graph. So whatever we do, essentially our logic is going to be in whichever coordinate system we solve the problem, our approach is going to be locate feed point, locate solvent point. Right? Something, the extract and the raffinate points should emerge from the tie line. Now, what is going to be feed point for a B-free calculation? I have already told it's going to be on a Cartesian coordinate system. So for the feed point, we actually need to know these two. Right? Are they known? Samira, are they known? Rishi, you can hold on for a minute. I'm asking people. At this point, is feed point known? Can you locate the feed point on a piece of paper, on a graph? Udrija? Varun? I'm requesting all of you to kindly go through today's class once very carefully. Udrija, how? What is NF? Since you have volunteered, let me get the whole concept cleared by you. NF is 0, very good. So you see, NF is 0. This is good. NF is 0 because there is no B in the feed. What about XF? What about XF, capital XF? Udrija, Varun, those of you who are writing NF is equal to 0, you are very close to the understanding. Rishi, Samira, XF can be found from the material balance is not exactly the correct answer. Udrija, it's even simpler. XF is known. Right? And it turns out that since it's a pure solvent, it's a B-free solvent, XF is equal to XF. Rishi, perfect. Is it clear to all? XF is known, the actual feed composition. And since feed is B-free, XF is equal to XF. Samira, where are you? Calling you several times. Bhavna, is it clear? Mausam, is it clear? Tejas, where are you? Awais, where are you? So you can look at the point XF, the feed point is now known. So when I asked whether you can locate the feed point, it is not that. Sahil, is it clear to you? Akhil Nama has left, removed from the meeting, few people. Ankit Verma, have you understood? Badri Vishal, Ayush Surana, Muskan, Bhagavati, Jay, Tejas, Pratik, Rahul Goldar, Ronak, Sajad Ansari, Saksham, Sajad Ansari, please rejoin. I just removed you. Please rejoin. Akhil Nama, Aman Kedia, Ankit Verma, Badri Vishal, Awais Akhtar. I keep on telling everyone that I follow Newton's first law. As long as I am good, nobody is better than me. But if I turn bad, nobody is worse than me. Bhagavati. Okay. Jay. Girija Karthik. Muskan Jain. I don't have to do any nautanki of asking people to turn on their camera and things like that. Rahul Goldar. Rishabh Kumar. Sajad, you have joined back. Sorry for removing you. Shashank Gautam. Somil, Sugata Murmu, Anuradha, Vaishnavi, Vivek Surekha, teaching at us, taking all the trouble for making everyone understand, and people are taking it for granted. This should send a clear message. I will send a very strong message in the group after the class is over. I'm very sorry that this batch has to see the negative side of me, but I think things were becoming a little too much. I will block some people and remove from the Microsoft Teams now straight away. Enough is enough. 30 people is good enough for the class. Okay. So we can now look at the feed point, right? This much is known. Now we go for a B-free balance. I'm teaching the toughest topic today. People are having fun. B-free balance. So what is the B-free balance? B-free balance is going to be, it's simple, B in F plus B in S is equal to B in M is equal to B in E plus B in R, right? So how do we get it? B in F is equal to NF into B dash, F dash plus NS into S dash is equal to NM into M dash is equal to NE into E dash plus NR into R dash. Okay. Now we know what is the stuff we know. NF is equal to 0. So this term goes away. So we are left with NS into S dash is equal to NM into M dash. Now here again, there is a little bit of assumption. There's a second assumption that comes in here. What is that assumption? Now we know NS into S dash is infinity and S dash is 0 and NS is infinity, right? What is it? NS is equal to B in S divided by A in S plus C in S, and S dash is equal to A in S plus C in S, right? All we do is we do not now talk about whether they are 0 or infinity or whatever, right? We simply look into their expression and get NS into S dash is equal to BS, which is the solvent flow rate, which is a measurable quantity. So here again, you bypass the mathematics cleverly. So what you write is this. NS into S dash is equal to S. This is what you write. And therefore, what you get is NM into M dash is equal to S. This is clear to all. We are cleverly in the framework of expressions writing this. Though in reality, one can always ask, sir, you are doing all this manipulation, but S dash is equal to 0. Only few minutes back, you have in the C balance, you have actually used S dash is equal to 0 and given it priority. So multiplication with S dash is equal to 0 was given a priority out there. And here you are giving priority to the expression. So you can say this is assumption 2, but this is how it works. And if this is now obtained, then what you find is NM is equal to S by M dash, right? S by M dash. Now, let me ask you, so agreeing to the fact that I hope that all of you have understood that whether the feed point can be located. Feed point can be located. I'm going to the graph. We have still half an hour, so that is good enough. In order to locate the feed point on the graph paper, we need XM, XF, and NF. And we now know that XF is known, NF is equal to 0. So feed point is known. Similarly, after this point, and let me tell you, this is, I won't say it's complicated, but it's cumbersome. I mean, you need to really practice it a couple of times to get a good grip. It is not the easiest concepts. And I have kept one question on hold, why at all this is important. Okay. So now my question is, can the point M be located? And in order to locate the point M, we need to know these 2 points, these 2 values, right? Advija, that's right. So if you know these 2 values, then you can locate the point M. Now, what is XM? Somewhere we have shown XM is equal to XF, right? And XF is known. So what we have shown, we have XM is equal to XF and XF is XF. Why this is important? Because capital X values have no meaning, because in a stream, you cannot really find them out. You can only mathematically calculate once the feed composition is known or the stream composition is known. However, XF is a physically measurable quantity. This is extremely important. Repeatedly, I'm telling. This is a physically measurable entity. For a pure for a B-free feed, XF turns out to be equal to capital XF, and for a pure solvent, capital XF turns out to be capital XM. So we can see that XM is known, right? XM is known. And what about NM? NM, see, very good, Advija. NM, you see, is S by M dash. S is a physically measurable entity, and somewhere we have shown that M dash is equal to F dash, right? And F. Somewhere we have shown F dash is equal to F. These are not the easiest concept. There is reason for me to get annoyed today. So you see, and nobody will teach you so slowly and carefully so that every point becomes clear. So somewhere we have shown M dash is equal to F dash, and which turns out to be equal to F. Therefore, the expression of NM turns out to be S by F. What is the advantage? Advantage is both physically measurable. Clear to everyone? So now we have XM and NM, both the points known, or we are now going to handle the graph with F and M known. Okay. Should be clear to all. Shayan, very good. You also got it absolutely right. And I'm sure those of you who are at least following the class, you have got it. And even if you have difficulty, those of you who are attending the class, once you listen to the recording and things like that, I can guarantee that it will be clear to you. Right from your second year, you have been trusting me and following the classes seriously. We haven't met. I have not met more than 7 of you, but still this class is very, very dear to me. Okay, so here is the graph now, and the graph that the axes are x or y over here and n over here. So this is the axis. Now we are back to simple Cartesian coordinate. Something that for the time being you have to trust me. Next class maybe I will make you draw this equilibrium plot. So an equilibrium plot, even on the triangular plot, you have not drawn it. So that is something we have to draw in the next class. So next class, all of you, please join, preferably with a printout of the blank graph paper, triangular graph paper I have shared, and a regular graph paper. Please join the class. I will announce it in the group with these two next week. Okay. So a equilibrium plot like this, in fact, one can have a lot of discussion on that, but I do not want to deviate. Equilibrium plot like this actually will take a shape like this in the NXY plot. You can refer to Treble's book also. Sorry, I think I drew it quite well. You can look into Treble's book also, but this will look something like this. And the tie lines, of course, you can look at the tie lines. Tie lines will look something like this. Simple questions. I mean, last week Samira had a question, how to guess a tri line or something like that. Everything we discuss in so much detail in the class. This is how the tie lines will look. Okay, so this is one thing you have to trust me for the timing. This is how, if you convert the data into an NXY plot, this is how it will look. Now comes the real interesting thing, Here, the approach was to locate the point S, pure solvent, there was absolutely no problem. And we located F, we joined them. From the mass balance, we got M. Now here, you see, the feed point is some value XF, NF. And XF is known, NF is equal to 0. So this is where my, let's say, feed point will lie. This is the axis starts from n equal to 0, and this is x and y equal to 0 to 1. Okay. Clear with everyone? But n does not have a limit of 0 and 1. N starts from 0, but can shoot up to very high values. Right? Because n has nothing to do with, because the definition of n is b divided by a plus c. So you can have a situation where the amount of b is much higher than a plus c. In fact, the solvent is precisely the case. But anyway, this everybody understands that this is going to be the point f. We do not know the value of xf, of course. Xf is something randomly I have taken. But we do understand that nf is equal to 0, and therefore it lies on n equal to 0, or the axis. This is clear? So everybody understands this is the point f. Now, according to this approach, what we have done, we have located this point. Now we should try to locate the solvent point, right? The next approach should be Sajad, you are back, no? Sajad Ansari, you are back, no? Okay, I'm sorry that I removed you, are still there. Next, we should try to locate the solvent point, right? Can we locate? This is clear to all. We are locating it to something, or we are comparing it to something we know very well now. We located feed point. Next, we locate the solvent point, we join them, right? So feed point we have located. Next, we should try to locate the solvent point, right? Next, we should try to locate the solvent point. Now, solvent point, what is going to be? So this is going to be the value of solvent point. This is 0, but the problem is this. Agreed? I'm sorry, this is not even 0. This is 0 by 0. Agreed? So what does the class conclude? This is a very, very important conclusion. For a pure solvent, you will feel so satisfied after this concept becomes clear to you. Is this clear? Rishi, you just hold on. I will not compare it right now. It is something different. Not exactly B vertex at infinity. Not exactly. But yes, in a way close. So you can just think of the triangular plot B, you are just opening it up. Something like that. But not exactly, not fully. More importantly, does the class now agree that for a pure solvent S, the point S cannot be located on the graph? This all of you agree? Right? So how do we proceed? How do we proceed is something very interesting. We also know what is the utility of the FS line. Good, Samira, too, that I saw your response. I was about to remove you also because in the middle I called you several times. So once, let's say, the point F is located, what is the utility? Think from a practical standpoint. What is the utility of the line Fs? The line Fs, wherever it intersects the value of xm, right? Very good, Varun. Hold on for your other friends. What is the utility of the line Fs? Utility of the line Fs lies in the fact that we calculate a value of xm. This is important. We calculate an xm, but we cannot actually locate the xm because only xm is not going to pinpoint the point. So we also need to know either the A or the B composition. And wherever the line Fs intersects with that value of xm, we get the point M. But now you see, luckily, point M is known. You see, point M is known, right? And where is point M going to lie? So this everybody agrees now that even without knowing the point S, we have successfully, with the two assumptions, been able to locate point M, right? And xm is equal to xf. Xm is equal to xf means that the point M is actually going to lie on a vertical line drawn at F. On a vertical line drawn at F. This is where the point M is going to lie. And of course, from the number, you can locate the point. I will get back to you on this. So somewhere over here, we are going to have this point xm, nm, yes or no? Why it is going to lie on a vertical line? Because xf is equal to xm. So a vertical line. And nm is known. Clear? So this point M is now located. One can be a little bit, okay, this is M only. This is not M dash. Yeah, this is M. So yeah, so point M is located. This is clear to all of you? Adrija, is it clear to you? Samira, is it clear to you? Or in simple terms, we are now starting to plot the graph. XF is known, M is known. And it turns out how to get the point M. Xm is equal to Xf for a pure solvent. Therefore, it's going to be on a vertical line. And Nm, whatever is the value. Do I tell the class anything else? Or the class can handle? So, of course, once you have, so what is the implication? Implication is we are not locating the point S. The point S lies at infinity along this line. But infinity cannot be plotted, so we are unable to plot it. In fact, the major difference with an NXY plot versus a triangular plot, right? The major difference of an NXY plot versus a triangular plot for a pure solvent is the graph is on the graph, you cannot locate the point S. I again request all of you to kindly go through the whole derivation once back and forth. Please feel free to consult Treble's book and things will be absolutely clear. Now point M has been located. So Samira, what is the next step? Or Varun, what is the next step? Rishi, what is the next step? Tie line through M, perfect. So next, all we need to do is to draw a tie line through M. And all those corresponding tie line, perfect. So all of you, whoever has responded has given the correct answer. So we draw this tie line, right? Once we get this tie line, we actually get these 2 points. E and R. So similar to the triangular plot now, from the graph, we get what? We get YE, NE, and XR, NR, right? And so finally, we can use the C component balance. So these two are now known. So now we can use the C balance once again. This is easy now. This part of the C balance, M dash XM is equal to E dash YE plus R dash XR. So all we do is we simply M dash XM is equal to E dash YE plus m dash minus e dash xr. And from here, you can find out that e dash is equal to m dash into xm minus xr divided by ye minus xr. So all these are known now. M dash is known. So what happens is E dash gets known. Abhishek, I'm coming back to you. Wait a second. Just 1 second. E dash gets known. And once E dash is known, of course, similarly, you can calculate R dash also calculated. And once that is done, what we can do is E turns out to be E dash into 1 plus NE, and R turns out to be R dash plus 1 plus NR. And this way you can calculate. Yeah, Abhishek, what is your question? Let me see. That's a simple typing mistake. And see, nobody pointed it out. Very good, Abhishek, Rohit, that you pointed out. XM, NM. It was a mistake. Typographic mistake. Either nobody cared or everybody somehow unknowingly wrote it correctly. Thanks, Abhishek, for pointing out XM, NM, and this is XF, NF. Turns out XF is equal to XM for a pure solvent, therefore it's going to be on a vertical line. Abhishek, clear? Sorry, it was a mistake. So this part, if you do, so now you see that very similar to this triangular plot where we could find out YE, XR, E and R, we have also been able to find out. I won't teach the multi-stage thing today. I will take up problems in the next class, and sometime I will teach this multi-stage thing. Actually, Saurabh was not here, and he requested me to take last Friday's class, but somehow I was not feeling well at all, and therefore I had to cancel. Otherwise, I would have never cancelled the class after I announced it. One question nobody asked me, that this probably you have probably more agreed to what I have taught rather than have developed a great concept of your own. You need to spend time on this. So yeah, when I was teaching, I was highlighting this is equal to this, that is equal to that. You probably have agreed. So you have all the resources to understand. One critical question that quickly comes to your mind is, if triangular plot was so convenient, why on earth we want to go for such a complicated calculation procedure with all sorts of hypothetical entities, B free flow rate, stuff that does not exist, etc., etc. The only advantage is that this calculation you have now brought back onto a Cartesian graph paper or a regular graph paper. Most of your graph generating softwares actually work on XY plot. Triangular plot is a non-conventional one. That is one of the things. Then the other thing, that is what we had already discussed in the previous class, there was another approach which I showed that you could easily do it, right, on the XY graph paper. That was the X versus Y type approach and the operating line and the stages marking on that. For a single stage, I have not done it. It's a 2-minute thing. Why not happy with that? The reason for that I explained. I hope it is clear to all of you that if you just, instead of this NXY plot, if you just go for this X versus Y plot, right, you lose the information about composition. Is it clear? So this is, in a way, advantageous, like it is on an XY plot, and you do not lose any information. Is it clear to all? Then I will stop the class here. Thank you very much. But my request to all these 30 people who took all the trouble of attending the class, waking up on a early morning, and many of your couriers probably are waiting outside with Valentine's Day gift. Well, some have to send courier and some will be receiving it. You attended the class, so I hope that you do justice to yourself, right? By kindly going through what I have taught. This is not the easiest concept, right? So all of you have a great day, great Valentine's Day, and share good pics if you want at the end of the day. Thank you. Bye-bye. Thanks, everyone. Assignment deadline is for everyone. See, there are a lot of advantages of being on an IIT campus. There's a small price you pay. You find so many people to pass on gifts, or at least you think you can pass on gifts. That's because you are inside an IIT campus. बाहर जाने से competition बहुत ज़्यादा होगा. Siddhant, where are you? I was calling you several times. And Onik, I do not teach all the subjects. So other subjects, there are more accomplished colleagues of mine who give assignments. For me, even setting up assignments is a problem. I don't have time. Have a nice day.